Hello, everyone. I should be coming in loud and clear now. Connor, can I get a mic check from you? Gotcha. Awesome. Hello, everyone, and welcome to the first ever Damage Analysis Live. And we have a special one on deck today with the 2021 Western Kentucky EF4, or more commonly known as the Mayfield tornado. And right off the top, before we dive into today's damage analysis, I have a couple of administrative notes. As I'm sure all of you are aware, there is a tornado outbreak that is currently ongoing. And if you are in that risk area, please feel free to turn this off, watch it at a later date. I'm going to re-upload a more condensed version of this presentation today. And then, of course, the live will be in the live portion of the channel if you want to go back and watch this. So if you don't feel safe watching this now and you want to stay weather aware, completely understandable. You know, I tried to schedule this thing a week in advance just to give everyone notice. Little did I expect there to be another tornado outbreak in December, but it seems to be a common theme in the past couple of years. So with that said, the other thing I wanted to preface up front is that I'm not going to be... Yeah? My camera's lagging? Oh, classic technical difficulties. Is it like my mouth is out of sync? Or is it a frame rate issue? Okay. Sorry, everyone. Technical difficulties to start this thing off. We're gonna make sure this is good because, I mean, this is the exact same setup we had last time. I don't think we had this similar issue. I wonder if there's anything I can change on my end here to make it better. Okay. It's better. Okay, much better. I literally did nothing. So, okay. So as I said, if you are in the risk area for today, you know, in the Tennessee, north of the border into Kentucky, and you don't feel safe watching this stream and you want to stay weather aware, completely understandable. Obviously, I scheduled this thing a week out. And I mean, it did look like there was going to be severe weather today, but I didn't expect anything like this to happen today. I wasn't super in tune with the forecast, but I don't know, maybe something to look at down the road, I guess. But today's topic is obviously Mayfield. And oh, yes, the other administrative note is that questions will be captured. We have Connor on standby today. He's going to be monitoring the chat today and capturing all your questions. I won't be able to see your chats in real time like I typically do. I'm going to be kind of running through this whole thing. So if you have questions that come up, the second half of the stream is going to be dictated by you guys. So I'm going to run through the things that I found interesting about the Mayfield path. And if you have things you want me to look more in depth at, we can do it real time. Maybe even crunch a couple numbers or something like that. So with all of that said, all that administrative stuff out of the way, let's get into the first ever Damage Analysis Live. Oh, oops, if I click my presentation. Am I in present mode? Wow, we're really off to a hot start. Come on. There we go. Awesome. All right. So table of contents for this. Okay. Where are my previews? There we go. Perfect. There we go. All right. So we're going to do a little bit of an introduction to kind of lead this thing in and kind of get into the case study and just kind of go over the rough numbers like we typically do in the damage analysis here. We're going to get into the background of the weather setup at play that led to this event. And then, of course, the SPC associated forecast. And then, of course, the meat and potatoes, the damage analysis itself. We have a couple of key areas that I wanted to focus on with this damage analysis. So we're going to get into all of those, and I think there's great lessons out of all of the things that I've brought and prepared for today. Then we'll have conclusions and some of my final closing thoughts, and then of course the Q&A to open things up. We'll dive back into the questions you asked during this, and then also kind of look into other areas that you guys are also interested in. So quick little introduction about myself for those that might not be familiar. I'm Ethan Moriarty. I'm a mechanical engineer by training. I've had my degree. I got my Bachelor of Science in Mechanical Engineering from Quinnipiac University. And then the weather component comes in. I storm chase. I'm a storm chaser. I've been fascinated by weather my entire life. And I've been chasing for over 8 years now, starting in my native Northeast states and then, venturing out west within the past few seasons. June 1st, kind of how it came to be, was in 2018 as a research initiative as a part of my undergraduate studies that I had the opportunity to develop some sensor packages and other cool engineering projects that were related to the research of severe weather. So that's how June 1st started, and then the channel kind of evolved later in time with more frequent uploads within the past 2 years. A mission statement that we have here at June 1st is that June 1st severe weather research is using engineering methods in 21st century media to enhance the understanding of severe weather. Just to kind of give you an idea of what we do here at June 1st, kind of one sentence that kind of encompasses everything that we do. So obviously today's case study is the Western Kentucky EF4 tornado, which took place December 10th, 2021. It has a very impressive path length of 166 miles. Yes, that is right. I mean, at one point in time, we thought this was one continuous tornado. Obviously, the Manette tornado that originally touched down, we thought it was all one continuous track of over almost 250 miles, I think. But the storm did cycle. But nonetheless, 166 miles is not something to turn your nose up at by any means. It peaked out at a width of over 1 mile, just over 1 1/8 mile. It was on the ground for an impressive 2 hours and 54 minutes, so effectively 3 hours. And then, of course, the human impact, this being the most impactful tornado to have impacted the United States in the 2020s, with 57 fatalities and injury reports over 500, depending on the source, ranges from 508 to 533. And then there's the material impact with an estimated $3.5 billion of damage. And of course, the official National Weather Service rating at EF4 and the estimated peak wind speed of 190 miles per hour. Getting into the weather of this event, wintertime, or transitioning from that fall into wintertime, we get, a much more active jet stream during this time of year. And it was no different with this event, big, giant, sweeping trough across the United States. And then as we start kind of narrowing our way down, getting into the lower levels of the atmosphere here, we're kind of seeing the embodiment of the influence of the surface low here that is kind of over the intersection of Iowa, Missouri, Kansas, Nebraska, all in there. So this thing, though we're kind of looking at one period of time when this is all taken at 0Z, the day of the event. So right before the tornado touched down, actually, this surface low kind of translated eastward with, the giant digging trough at the surface, and even up in the upper levels here, you kind of get that very subtle short wave that initiates the height falls for that isolated storm, gets that thing going. And then kind of just some of the other parameters here just to get an idea of what we were dealing with. So effective storm relative helicity, we got some pretty intense values here of, pockets of 400 and 500 meters squared per second squared. And then getting into the mixed layer cape, instability in the mid levels there. So plenty of stuff to get a storm going, but the real kicker when it comes to this event is, just the shear profile as a whole. A classic long tracker type photograph that, once that storm gets going and, taps into an unimpeded environment, it's just going to churn, right? So that kind of gets into the, quick overview of the meteorological aspect of it. Obviously my focus is a lot more on the damage side of things. If you want a more in-depth look at the forecast side of things, go over to Convective Chronicles, give Trey another view over there. He breaks down the event in his way in a much more detailed and more educated fashion, especially since I am not a meteorologist by training, just a storm chaser that looks at big picture ingredients. Getting into the forecast from the Storm Prediction Center here we have the day 3 outlook. So we have, a nice broad slight risk. So the Storm Prediction Center, I believe on the day 4 there was mention, but it was still, not confident enough to really nail down a target area. But on day 3, they put that broad slight risk over what would eventually be, that prime zone. Going into day 2, they upgraded to an enhanced risk. And then midday on the day 1, there was enough evidence to support a moderate, so 4 out of 5 risk with a 15% hatched tornado probability. So let's get into the damage analysis itself and take a look at the path. Obviously, this is a super long, chunky path that is a lot to take in. And I think a big thing that we have to take into consideration here is just the sheer logistical nightmare that it must have been for the National Weather Service and the other emergency coordinators that it took to kind of be able to cover and document this whole thing. There was unprecedented use of UAVs, and this is, obviously it's tough to really respond to an event like this, right? So I just wanted to spell out my appreciation for the National Weather Service offices in Paducah and Louisville, which conducted the survey of the Mayfield tornado, and obviously the other parties. There was engineering oversight as well that really led to this survey being completed. Kind of looking at this survey chunk by chunk, we kind of start just over the Tennessee border, and then it translates into the Kentucky. So, the first mile of the tornado basically is in Tennessee, but then, makes its way into Kentucky, with the first instance of EF4 damage actually occurring relatively early on in the track. But then as as the storm kind of, gets off and running and translates further north, directly impacts the city of Mayfield. The Candle Factory is a place of immense destruction, and then obviously downtown itself, those two areas being highly concentrated for intense damage. As this thing kind of continues its way northward, still producing heavy damage. This thing's just reaching a cyclical state and just basically churning away for dozens of miles at a time. And fortunately, kind of after Mayfield, there's a big gap in populated regions, but that unfortunately does not stay that way. The tornado skirts north of Benton and then eventually ends up in Cambridge Shores, where there's significant EF4 damage along Kentucky Lake here, and it kind of works its way over the fork of Kentucky Lake and over the Cumberland River, and then just skirts to the south side of Princeton. So another, major population center that was just missed, though there were impacts obviously in the community of Princeton. The next big hit area is Dawson Springs, which takes the direct hit from the tornado. A couple instances of EF4 damage there. And then arguably the most intense area of the track is just northwest and west of the small community of Bremen, Kentucky. The highest rated DI, which we're going to take an in-depth look at later, of 190 miles per hour, fell in the Bremen area. And eventually this tornado continues so far that it leaves the jurisdiction of NWS Paducah and continues into Louisville's WFO area, and ultimately produces EF4 damage for the rest of its life before roping out north of Falls of Rough, Kentucky. So now that we've kind of gone over and gotten a bird's eye view of this track, let's dive into a couple of specific areas. And the first of which is the infamous candle factory, which is Mayfield Consumer Products. This factory was directly impacted by the tornado and was the first real structure that was heavily impacted within the confines of Mayfield. Kind of a before and after here from satellite imagery of the structure. Unfortunately, at this facility, there were 9 fatalities, so 5 workers that perished in this tornado under the roof of this facility. And while we don't have any real up-close images of the candle factory, of the damage, and at least publicly available, other than from news crews and stuff, nothing officially on the damage assessment toolkit. I'm not sure if that has something to do with maybe potential lawsuits and stuff like that are taking place, given the some of the stories coming out of that. But the open floor plan structures, so these big industrial type areas where you have these huge, long, expansive workspaces, are possibly one of the worst areas you can be when it comes to a tornado. These big open floor plans offer no real structural rigidity, in a sense where if you have say a building of similar size might be like an elementary school or something, right? As we see that this building was kind of like a 1-story. It looks like they had offices in this corner, and the factory floor kind of tucked in the back here, at least from the street perspective. It's kind of important to realize that compartmentalization is adding like structural rigidity throughout the structure. So as you are adding wind loads to your external walls and stuff, all of these walls that are kind of bracing all of these walls are gonna prevent kind of like any sort of caving in or anything like that. Or if like the roof blows off or something like that, it's not gonna pull the walls down with it. So with these large open floor plans, you're going to have, unfortunately, once kind of you hit one real failure point, it's just going to be like kind of like a chain reaction where the whole wall is going to fold in, the whole ceiling's going to come down. And with a lot of these open floor plan manufacturing places, there's not like a lot of like you can basically see like a lot of like the overhead roof structure and all that fun stuff, and that stuff's just going to come down right on top of you. And unfortunately, in the case of the candle factory here, if you weren't sheltered in like an interior bathroom or anything like that, you're going to be subjected to the wrath of the tornado, basically, and the debris of what's around you. And also keep in mind that this being an industrial facility, who knows what type of machinery is going on in there, what types of chemicals are being mixed, and all sorts of hazardous stuff can take place within this place. And I can imagine being a first responder in this instance and being like, okay, like what are we dealing with here? Like, what could be leaking that could be hazardous to myself, never mind the people that are in this building. This is just all sorts of things that could possibly go wrong. It's a worst case scenario when you hit something like this. And unfortunately, the candle factory could have learned from like the Roanoke event back in 2004, that that plant that was impacted, I believe it was a fertilizer plant, if I'm not mistaken, everyone sheltered and everyone made it out alive once that tornado warning was issued in the Roanoke event. But here, there was lead time on this tornado. There was, tornado warnings. It was on the ground for, over 15 miles at this point before reaching Mayfield. Whatever the chain of command was doing there, it's kind of scary to think about and sad to think about that, there's a lot that probably could have been done here, and we could still have 9 lives here on this earth today if the proper measures were enacted. Getting into the downtown area a little bit, I just wanted to kind of point out a couple of things. There was obviously a lot of structural damage in the downtown area, but kind of looking at some of these larger, huge masonry type structures that look like these big, formidable structures when you're standing next to them, I think there's a good emphasis here in that, when that warning comes out and it says get to the lowest level, you can have a super intense tornado hit. And if you can get to the lowest level of that structure, you're going to stand a much better chance of surviving than if you're in the upper levels of what might seem to be an extremely sturdy structure. So just looking here, if we have this kind of, if you were in the second floor of this church here, we can see a nice exposed doorway here. If you were sheltered upstairs or something like that, who knows what could have happened there, right? So just going a little bit further here, this is what the building looked like before. So kind of get a sense of, what could have been the case. Quick water break. I'm not used to usually talking this much, but that was kind of the main thing I wanted to get away here. When that tornado warning comes out, get to that lowest point in the building. All right. Narrowing it down into downtown Mayfield, one of my favorite examples of, just to kind of show the power of this tornado is the water tower. I like looking at water towers because they're marvelous pieces of engineering. The idea of using converting potential energy by storing water up high to give yourself water pressure is kind of an amazing concept that we've been doing for thousands of years in the Romans. But this isn't a history of this isn't a history of infrastructure. So I'll avoid the nerdy details. But getting into the water tower here in Mayfield. Obviously it collapsed under the tornado and obviously suffered a catastrophic failure. And, the structural members here that, you could obviously tell had failed. And the main thing I think happened is a buckling failure. And we're going to get into it a little bit. We're going to get into the nitty gritty math details that everybody loves and kind of back calculate and see what we can figure out in terms of an approximate estimated wind speed. Granted, there are a lot of assumptions that we're going to have here with this water tower. So a lot of the geometries I had to approximate, I tried finding blueprints on this water tower specifically. I couldn't find anything concrete, so I had to use the satellite imagery and using shadows and stuff like that in order to approximate geometries for this thing. So not an exact, full encompassing geometrical layout that I have here, but they're pretty reasonably close, I think. We're assuming this is an all-steel construction in terms of the material properties that we're going to be analyzing. We're treating this as a uniform wind load across the body, and that the main, kind of acting point on the structure is going to be the actual vessel that holds all the water. We're assuming no prior fatigue stresses or anything like that. So fatigue stresses are residual stresses that build up over time. The best way I can think of a fatigue stress is something that gets cycled over and over and over again. So maybe like a car suspension spring or something, or like a wheel bearing, for example, something that's constantly, moving over time. That shaft and the elements of that wheel bearing and stuff are going to slowly, get weaker and weaker over time. This is also assuming no corrosion or anything, compromising the structural integrity of the water tower. And then I'm assuming that this thing is at full capacity. So this is a 500. I was able to at least get that this was a 500,000 gallon water tank. While it most likely was not at full capacity, at night, this is when the water towers are, refilling back up and from all the day's use of water. So this thing was probably pretty full, but not 100% full, obviously. And then also, I'm assuming at full capacity because I'm compensating for the weight of like the structure itself. So we're just going to use the water weight of a full tank to make up for the steel and all those weights. So kind of diving into some of the geometries here and what we're going to expect happen. So imagine we subject this wind load here along the side of the water tower, acting along the center of or acting along the centroid up here. We're calling this like basically these spindly little legs. We're not going to really, shift our CG down. We're just going to say it's dead center because we're calling this a nice full tank. And then the legs are negligible at that point. And then we're going to basically see some sort of buckling failure. Like one of these legs, depending on where that wind vector is going to be subjected to the most of that load, because it's going to be, so if this is the water tower, it's going to be pushing it over. And as you can see, like as I push my water bottle over, if this is on a flat plane, all the stresses are going to build up on this side of the water bottle, right? So one of these legs is going to be subjected to the most load, right? So that's what we're kind of illustrating here. So if we kind of pull a detail of one of these legs here, you kind of have this big moment arm that's pushing on this thing, and basically you're going to get what's called buckling. And if you took like I don't know if I have something that's really super indicative of buckling, but like if you're pushing down from the weight of this thing, eventually your pillar is going to like push to one side and like break. It's going to buckle. And buckling failures are pretty common with any of these types of, tall, lanky type structures that, have these big, long, spindly legs. So this was, as I mentioned earlier, a 500,000 gallon capacity water tank. And if we multiply, out the weight of, each gallon of water is about 8 pounds. You get 4 million pounds of water. Divide that across 8 columns. So that means that the weight, each column is having to deal with 500,000 pounds of weight on top of them. Getting into the steel properties a little bit, this will make more sense in a second once we kind of reveal the buckling equation. The Young's modulus, so it's kind of the relation. Young's modulus is the relationship of stress in a material compared to the strain of a material. The strain is like how much it deforms. So it's like you get your deformation and then your stress. So it's like it makes a curve, and the slope of that curve, or the approximate slope of that curve, this is getting really into material science, but for the for the first part of that curve is pretty linear because it's in the elastic region, which means that if you deform, a certain amount and add that much stress to it and let it go, it'll go back to its original shape. But once you go past that region, you go into the plastic region. In the plastic region, Young's modulus no longer applies because you have permanently deformed the object. So nonetheless, Young's modulus is that slope in the elastic region. And in the case of structural steels here, it's 29,000 KSI or 29 million PSI. Now getting into Euler's buckling formula. This is your buckling formula, and here's that Young's modulus that I was talking about earlier. I is your area moment of inertia, so that takes into account the strength of the shape of your cross-section of your column. K is your end condition constant, so this basically, depending on how your column is supported, so if you have like two fixed ends, it's going to behave differently if you have maybe one fixed end, and this end is allowed to translate a little bit. And in our case, because our end up here is allowed to translate, the wind load is pushing on this structure and kind of allowing this end of our column to kind of deviate a bit. It's not fixed in place. That K turns into 1, and then here's our area moment of inertia. This is just a calculation of our cross-section of the column here. Calculating that out, we get our buckling critical force here of just under a millions pound force. So this is kind of the criteria now that we have to compare towards for that failure of the column. We subtract away the weight of this, and then we have this kind of 400,000 pounds force that's remaining, and that is due to the moment of the wind force. So this is that extra force that's pushing down on that column that it needs to buckle. And you kind of have to compare the moment arms about the origin of your body, if you will. So you set these moment arms equal to each other and then calculate them out to get the real wind force that's acting on the structure, because of this smaller moment arm compared to this huge moment arm, that force is going to get drastically reduced because there's so much more of a mechanical advantage there. And then if we continue, we can plug that force that we get from our buckling, our back-calculated buckling into the back-calculated moment equation in order to get the force of drag equation, which actually gives us the approximate value. So we have our air density term, we have our velocity term, which we're going to be solving for, get our platform area. So that is like, it's not like surface area. Surface area is like if you looked at the entire like outer edge of this volume and like calculated that area. Platform area is like what the wind sees. So we can basically approximate this as like a rectangle. It's like close enough to a rectangular shape. So it's just what the object sees. So like obviously the wind's going to be coming from this side and it kind of just sees, this bulbous looking thing. And then the coefficient of drag, I looked up coefficient of drags, and because this thing's kind of spherical, I kind of used the coefficient of a drag of a sphere to calculate this, which is 0.5. And then with all those values, we're able to plug them into our velocity equation. So we got our our force of wind here, the density of air, the platform area, and our coefficient of drag, and get a final answer of 299 feet per second or 204 miles per hour. Now, does that make this a EF5 DI? Well, not really. Obviously, there were so many assumptions that went into this that, something that of a threshold that's close, it's like, I don't know if I'd be comfortable calling that an EF5 DI, but it just goes to show that, you can kind of, with some pretty reasonable assumptions, get a pretty approximate, reasonable answer in terms of what type of wind load would be needed in order to topple a structure of this magnitude. Water break. And, obviously we have all of these assumptions. So it's kind of hard to really pinpoint like what the actual failure criteria would actually be without maybe some crazy, computational fluid dynamics simulation and really modeling this thing and putting in, all sorts of parameters for, like corrosion and all these other factors depending on how old the tower is and other fatigue stresses and other micro things and joints and all this stuff. But this was a fun example. This was one that I went through not long after the Mayfield event had happened. So definitely a very interesting case study to kind of dive into in terms of, picking out a DI that wasn't actually rated in the official survey. Moving forward here, this is a image from Bremen, Kentucky, of a mobile home. This was thanks to Kelton Henderson. I meant to attach the little courtesy label here, but this was actually a screenshot that I used in the mobile home video if you had the opportunity to watch that. But this is a really interesting DI because I think it goes to show just how dangerous sheltering in mobile homes are. I mean, never mind a weak tornado, but in a powerful tornado. We all know that mobile homes are severely compromised structures when it comes to tornado safety. But over here's the origin point of this trailer. And then, some ways later, here's the frame of it. And then, of course, all the debris from it kind of scattered. And if we kind of take an aerial look at this thing, it's pretty remarkable. Just how far this thing seemed to have carried before it kind of, impacted into the ground, Like, I'm guessing it impacted back here and kind of shredded apart and continued to tumble a bit. I mean, it's impossible to say, but that's kind of what seems to have happened here. That there was at least some sort of distance where this thing was definitely airborne, given the lack of, anything in the front yard, or even, over the road here. It seems like everything kind of starts here, and maybe this is the impact point and just continue to roll for a bit. But, if you're in that type of structure, that's not going to be a fun time, that's for sure. Likely unsurvivable, if you ask me. So just the final resting place of that trailer compared to the origin. Unfortunately, this predates the last satellite imagery of this that was available on Google Earth. The home was installed after. So it must have been a rather new mobile home, which goes to show that, even if you have a newer mobile home, it's definitely not safe in an EF4, potentially EF4 plus tornado. So 330 foot carry is pretty remarkable, if you ask me. Now, diving into the principal rating, the classifier of the Mayfield, Kentucky tornado was this home right here at EF4 190. And kind of just looking really quick overhead, just nice satellite imagery, just kind of get an idea. So this is a nice, I think it's quite an adorable little house. And one thing to note is that it was an extremely new structure. So where this thing was, this was May 2019, June of 2020 in terms of satellite imagery dates. So this thing was built extremely recently and was probably not even quite just over 2 years old, if not newer, when this thing was impacted by the Mayfield tornado. Just kind of looking here, just a couple things to note. So we have a couple of different foundation types here. So we have, this kind of reddish color, and then we have this gray color over here. And then off over here, we have all of this like gravel type stuff going on, some substrate over here. And this is from the official DAT survey. I mixed in a couple of images from the homeowner of this property. He had posted numerous things online about the structure before and after the rating of this structure. But from the DAT here, so just to go show how new the construction is, the anchoring into the foundation here, brand spanking new. I mean, these are looks to be, if I had to guess, it looks like zinc plated steel, if I had to guess. And then we had toenailed studs here, and the remarkable thing is that they're like purely horizontal now, that they got completely yielded and bent over, which is pretty remarkable. But it's nice to see the presence of anchor bolts here. But nonetheless, if we kind of move further along here, this is the other kind of foundation here, and this is a garage, right? So if we go back to more again, so this is like your garage and your gravel leading into your garage, and then the rest of this was the rest of that house, right? So, kind of getting an idea of what's kind of the layout of this structure. This was one of the images posted by the homeowner, and we're like, okay, there's foundation over here. There's this garage poured pad over here. Where is the rest of this foundation, right? Like, all we see is this kind of gravel substrate stuff. Well, it is blown downstream from the original structure, right? And what I think happened here is quite remarkable, to be completely honest. So, we have the garage door here, the rest of your housing structure kind of around this building here. And based on the orientation of this structure, Here's a couple images posted by the homeowner of the construction of this house. So here we see the rest of that foundation, right? Where we saw gravel before, which was now lofted downstream, right? And then we got, the garage right there. And then keep an eye on this blue thing. This is important for later. But, your tornado and subvortice, what seems to have happened here based on there's some supplemental satellite imagery that's out there that I couldn't post in this presentation, but it was pretty evident that there was a strong subvortex that was kind of, doing its loopy thing this way. And, with those subvortices, they do those carouseling loops that you'll see carved into the ground with some of that ground scouring. And what I am thinking happened here is that, while this home was anchored to the foundation itself, that foundation wasn't really poured into the ground. It was kind of resting on this gravel substrate, right? So with the orientation of the garage and this overhanging canopy that we saw in that first image there, so, coming from this tornado coming from the west-southwest, and that garage door that is leading to this driveway, and then we have the overhang of that porch that faces south, along with this motion of this kind of, looping subvortices that are kind of wrapping around the main parent vortex, you kind of get these, these wind vectors that kind of either blow in this garage door or something along those lines, or catch that overhang of the house. And the house is so well built that it basically is getting picked up in almost one entire piece with some of the foundation still with it. And it just, it was obviously evident that this house was extremely well built based on, the anchoring and, the care that this homeowner took in to designing and building this house. Going back here to, even the bordering CMU blocks, we have poured anchor points into the actual ground, which is always good to see, but it wasn't quite enough. And this whole house was so well constructed that, again, this is what I theorize happened, that, these critical failure points, as we know in previous videos that we've done, that garage doors, when those things implode, the structure is in trouble. And, that big overhanging front porch was just going to pick this home up as whole and then kind of smashed it later downstream. And then why this thing got EF4 versus EF5. So let's dive into that a little bit. The homeowner posted on his social media a conversation with one of the surveyors, and in here he goes, one thing that stood out was, we'll just read the whole text here. We are comfortable with an EF4 rating, about 190 miles per hour. I would be happy to share the engineering perspective of what failed on your house, but a big part of the rating is the entire scene around the structure. One thing that stood out was the tree stand right beside your home was not totally leveled. If you look at EF5 tornado damage and pictures it, you will see that the trees are gone. Anyway, you built an awesomely strong home, and the engineers say there were a few things that could have been done to make it stand to even stronger winds. They were mostly in the foundation, in the scheme of things would not have added a lot of cost to the home. Again, I will glad to share those as well as I can. But I think the engineers that surveyed this property were probably getting at was the fact that this foundation wasn't like, the foundation itself was kind of sitting on top of this gravel substrate and wasn't like poured into like the ground itself. Obviously most cellars and stuff like that, you kind of pour the foundation, into the ground into some capacity. So I'm imagining it's something along those lines, because other than that, we saw along those sill plates that, they were anchored into the foundation, but anchored to the point where it picked up the entire house and threw it basically, right? So the tree that they were talking about in question was actually, 125 feet from, the center of the property there. But if we look at some of the NWS presentations about tornado damage, in one of their own presentations, they classify this as solid EF5, but yet there's, standing trees and stuff still around. So, it comes back to the subjective nature of the EF scale, which is, ultimately its biggest downfall. Because I think that, given the quality of construction of that house, I don't think it's completely unreasonable to say that, in some of these images here that, arguably just on the context of the damage of the house here that, EF5 is definitely, I don't think, out of the question entirely for sure. But, that big question mark in terms of, whether or not that foundation, was really kind of cemented into the ground here. Maybe that would have been a much more saving grace. But actually, I don't think that the structure would have actually survived. Just based on, the fact that we have, these sill plates that are still anchored here and the walls gone. But I wanted to call back your attention. I called out, this corner of the garage for good reason. And honestly, I think this is the most important thing that can be gathered from this DI. And these were images posted by the homeowner of the storm cellar that he installed in the garage here. This is where they rode out the tornado. It doesn't get much more clear cut than that, folks, in terms of a storm cellar saving lives. That's for dang sure, if you ask me. This is possibly the greatest advertisement for a storm cellar I could have ever seen. The homeowner, I'm pretty sure, has built back a structure and has installed another one of these storm cellars, and for good reason, I would say. Moving forward from that 190 mile per hour DI, there's a couple other areas in Bremen that I think are worth exploring here. And this EF4 damage indicator rated at 170, though there wasn't anchoring at this location. We could kind of see the pad of a foundation here. The granulation of the debris in this particular DI, I think, is quite remarkable. And I think the granulation alone here, though the structure itself was not anchored to the foundation sufficiently, just the pure granulation of foundational materials and stuff here, I think is another point where you could maybe argue the point of EF5, right? Again, we're talking about these kind of the tree questions, and my problem with trees is that trees are so variable, and I've never loved debarking and those types of indicators in the first place, because how do you how are you able to analyze debarking and stuff like that, right? So it's those types of things that always leave me scratching my head, whereas structures are much more easier to kind of quantify, in my opinion. But kind of looking at a couple more of these DIs nearby, if we zoom out a little bit from that house, this is another drone photo courtesy of Kelton. But just the windrowing here of debris downstream, reminds me of a lot of, some of the damage that we saw in a tornado like Rochelle, for example. Just debris that's, just completely swept away from the foundations themselves and scattered for hundreds of yards. So with that kind of concludes my, my observations of the Western Kentucky EF4. The main areas that I wanted to dive into. The main things that I'm kind of gathering from this survey is that in this part of the country, there is a lot of poor construction quality. Obviously we kind of touched on it a little bit here and there, but obviously there were several notable exceptions, including that, that 190 mile an hour DI, for example. But there are a lot of structures in here that maybe could have fared better if there were some better construction practices used. Below ground storm shelters are life-saving investments in new home construction. If you were above ground in that 1 mile or in that 190 mile an hour DI, that was a non-above ground survivable structure. Simply put, that in-ground storm shelter saved the residents' lives without question. Kind of unrelated to the damage itself, but kind of more the socioeconomical I'm not an English major, guys. I'm going to be completely honest with you there, but I'm going to kind of dive into it a little bit here. But Mayfield, based on the most recent imagery out of there, may never recover. And, we're 2 years removed from the event as of tomorrow, and things do not look good in Mayfield, to put it simply. And then kind of one last thing here is, I think that this tornado kind of lands in that list of EF4s since the Moore 2013 EF5 that have a legitimate argument for, a potential EF5 rating. I mean, obviously there's like El Reno in 2013. If you completely ignored like the damage side of it, and if you do go off of those wind measurements, obviously El Reno would fall squarely into EF5. Valonia, Rochelle, those are two that, very well, under a different set of circumstances. I bet if you took Valonia or Rochelle, and if they happened in maybe 2000, like 2008-9 time frame, right in the early days of the EF scale, that those very well could have earned EF5 ratings. And then now Mayfield. There's a bunch of others that you could probably add to this list too. But those are the ones that really stick out in my mind that, if maybe if they had to have happened earlier, closer to the inception of the EF scale, and, now with the way it's interpreted nowadays, these types of tornadoes, I think, could have very well earned EF5 ratings, 10 years ago, as opposed to more recent history. Well, I guess 10 years ago now is 2013, so did I say 15 years ago? Something like that. Time flies, right? Just diving into the impacts of Mayfield post tornado. This one kind of breaks my heart here. So this is Mayfield in 2019, so a couple years before the tornado. Nice little cute downtown. We got these nice little flowery trees and all that. Cars lining the streets here. Businesses, these kind of old, beautiful buildings. I love these old brick masonry buildings. And this was October 2023. Same intersection. Not like you'd really be able to tell. Yep, there's that parking lot that we kind of saw there, right? Parking lot. This building, I mean, it's been, 2 years since the tornado, and this thing's still, like, why is this thing still up and not, you can see there it is right there, the corner there, that window. Like, talk about the life literally being the soul of a town, just being gutted from this community. Like, obviously we can argue about EF5, EF4 at the end of the day, but like, does that really matter? 57 people died, and the soul of a community is just completely ripped away. This was 2 months ago, this image. It's been 2 years since the tornado. Like, is Mayfield ever coming back? I don't know if it does. Like, I don't know if it ever rebounds to what it once was. I like the flipping of between these two slides, is I'm actually like speechless, right? And then just going into the satellite imagery here, just all the empty plots. I mean, maybe maybe there's some new construction going on, but I mean, just based on this alone, doesn't seem like much is happening here. It's like, how do you rebuild a town like this? I don't know. And on that note, I guess that kind of wraps up what I wanted to present for today's damage analysis. It's a really heavy heart to kind of go through these, obviously. with the amount of fatalities and injuries, and you have to imagine that the trauma across the board, the thousands of people that have not only obviously there's 500 some odd injuries, probably, over 100 of those are probably, lifelong lasting injuries, right? Whether it be spinal cord or head trauma, like I can't even begin to imagine some of the stories that people have that are going to have to live with some of these things for the rest of their lives, right? Like that's what like kills me when we're looking at this type of stuff is like, and then you see things that could have been done better, like the damn candle factory, and you hear the stories out of there. Like, what are we doing, right? Like we love weather, right? Like all of us, like we're so passionate, but gosh, can it just absolutely gut you? So with that was my that was my spiel. Connor, questions that we have in the chat, or we can open up. We can start. Talking more damage. I still have the the full survey open here in Google Earth. Can always dive into that too. So I'm gonna also, guys, if you wanna, I mean, I know you're all here with live watching this right now, but I'm recording this right now, so I'm gonna condense it down and re-upload too if you want to see a more condensed version later on at some point in time. But yeah. Connor, let's dive into it. Let's dive into some questions. Okay. Let me get the screen going again. All right, so here we are. Here's the full publicly available damage assessment toolkit. We're talking about some of the brick buildings. Connor? Yeah, okay. So we just want to look at those generally speaking. Gosh, I hate when the DAT has the pictures sideways. I mean, these are like, some of these masonry failures are always pretty terrifying to think about. Like, look, like these are older buildings, obviously, and like, look, you can see like the floors. Like, what if you're on that second floor? You're just getting dumped into a pile of bricks, basically. Like, there's no way that's fun. All right. I'm gonna start I'm gonna scroll through. Oh, I see a June graph. Thank you for the outstanding, emotionally intelligent commentary. We need people like. Oh, that's too kind, June. I really appreciate the super chat and your kind words there. There are a lot of good folks in the weather community. There are a lot of great people doing great things. And I'm glad to be friends with a lot of them. Familiar face in the super chats as well. Thanks, Kurt. 2024 cast money. Of course, 2022 chasing season. Yeah, I got a number of changes coming up soon. Kind of deviating from the Mayfield stuff, but yeah, some big announcements coming soon. I'll put it that way. By the end of the year here. So Stay tuned for that. I'm gonna do like an end of the year video, I think, soon. Watching from Seattle. Nice. How much was the Mayfield tornado in damages? So that was, it was 3.5 billion. I think we had that in the beginning of the presentation. Yeah, I personally don't mind the EF rating. It's sad how Mayfield hasn't yet recovered after 2 years since the 20. Yeah, that's the worst part if you ask me. Joplin was an EF5 in 2011, correct? Yes. Joplin was an EF5. How did Greensburg recover so well? The thing is with Greensburg, I don't think has still reached the population number that it was when it was hit. I think it's still like 70% of what it once was. The downtown area is really nice, but there's still a lot of empty plots if you drive through Greensburg, which we did last year. We drove through Greensburg, and there was still evidence of the tornado, like a couple plots here and there of stark reminders of that Greensburg tornado. I think the best example of a city recovering from a tornado is Parkersburg, without a doubt. The best tornado recovery story, in my opinion, in terms of a community, is Parkersburg. Watching from Australia. Oh, awesome. Love that. Some other questions that popped up, Connor, from earlier in the chat. I mean, we can also look at more masonry buildings if we want to, or if there's anything else that's specific DIs that we want to take a look at. I know I kind of skipped over the Cambridge Shores area. This was an area that was also really heavily hit. Can you do a damage analysis video of the Joplin tornado? I want to do one on Joplin. That one's going to be a very involved one, because that was before the standardization of the DAT across all NWS offices. So there's no like DAT entry for damage assessment toolkit entry for Joplin. So it's going to take a lot more forefront research. Oh, good to see Kelton in the chat. Thank you again for providing a lot of your great imagery from the event. Kelton's documentary on Mayfield is also incredible. If you haven't watched it, if you click on his channel, I highly recommend his doc there. Is it possible to guesstimate wind lift on roofs? Yeah, I think the way I've always done that is kind of approximated. I've done it in a couple of these damage analyses where I've basically used like kind of like the pressure gradient, like kind of using the inside of the house as like the inside of the house as like a still at atmospheric pressure, and then you kind of use the wind going over top and using that to kind of calculate the low pressure on top and kind of calculating that difference, and then taking the square platform area of that house and then kind of calculating the uplift force off of that. Of course, also with the event tonight, obviously we've been seeing a lot of the imagery coming out of that leading up to this. I almost debated on delaying this live stream, to be completely honest. JM Studios, yes, Bernoulliing it. Yeah, I mean, Tennessee's such a great state too. I've had the pleasure of visiting Nashville. Such a cool city, fun city, obviously. But I actually went up towards the Nashville EF3 path and kind of walked through some of the neighborhoods that were impacted by that when I was last in Nashville in that was 2022. I was there, yeah, March 2022. So yeah, not that long after, 2 years after the Nashville and Cookeville event. Do I know? Oh, if this upcoming or do I have we'll take a quick look at what's going on GR Analyst. We're probably over here by now. I haven't looked in like an hour and a half. Come on, give me recent data. There we go. Oh. Come on. Give me data. I'm curious to see what's going on right now. Let's see, we got severe warnings, 2 tornado warnings, not observed. That's good at least. I'll get the Nashville radar site. Yeah, nothing crazy. Anyway, I just kind of wanted to see what was going on. I have friends that live in Franklin, Tennessee, so they seem to be behind the front now. But it seems as though that, yeah, I think the threat's going to be localized. I mean, probably winding down now. Lineared out. Okay. Still a ton of footage of JRL 97 that's never been released. JRL would be another fun damage analysis. Well, not fun, but Samuel Stewart, will it hit Virginia? I don't think it'll like as tornadic. No, I don't think so. I think that's well outside of the risk area. When will you cover Northeast state events? I want to recover more state Northeast events. I have a couple so I have a huge list of like video ideas that I have kind of stored up, right? And the next couple are I'll try to squeak in a Northeast one soon. May 15th, 2018 might be a fun one to do. That was like the second moderate risk in like 2 weeks in New York, in the Northeast. That was pretty crazy. Connor and I almost got hit by a tornado that day. cover the flooding on Monday, right? How do I? Out of all of the damage analyses you've done, which is the most interesting to look into? Ooh, that's a great question, Kyle. Now I got to think about all the ones. The first, like, I wish I didn't start with the Valonia one. The Valonia was like the first test run. Valonia was super interesting because that storm shelter, like I still think about that like on like a weekly basis almost. If that storm shelter like had the right door, there wouldn't have been that fatality in that storm shelter. Like I think about that one a lot. I think this Mayfield one was pretty interesting, especially that because a lot of times it's tough because like you don't have so much, you don't have like a lot of details to go off of. Like you're kind of cemented to the DAT and like maybe stuff that you can maybe find online, but that this one the 190 mile an hour DI here in the Mayfield one was probably the most like detailed one I was able to go in depth on in terms of like prior construction and stuff, just because the homeowner had posted a bunch of stuff about it on Facebook after it happened. So I was able to like kind of like, you know, actually get a real understanding of how this house was constructed and not try to like make a bunch of assumptions after the fact kind of thing. So that one was really good, and I'm really glad I got to showcase that here tonight. Where does the Tuscaloosa EF4 rank as far as the argument to be an EF5 when what happened to Mayfield has hallmarks of that debate but amplified? I have to dive back into the Tuscaloosa damage path, to be completely honest. I don't want to misguide it because I'm not like, it's tough. I wish I like, there's so much going on in my brain that I have a hard time like remembering all of the DIs and stuff in each damage path. I have to kind of refresh myself. So I might have to, you can hit me up in the Discord and if you want, Raymond. And I'll see if I can get back to you on that. I'll have to dive back into the Tuscaloosa path. Yeah. Chris said a fatality in a storm shelter, like it's like you're doing like all the right things and then the storm shelter is like had a critical design flaw. Like what the heck? Crazy. Can you do a analysis of the Pembroke Black Creek, Georgia EF4 from 2022? There was no PDS or Tor E tag on it. Yeah, that might be one I'll have to add to the damage analysis list. There's so many. What do I think of New Ren EF3 2011? New Ren very well could have been the 5th EF5 that day, in my opinion. I think that, the problem with the New Ren tornado was that the lack, like what I think prevented that tornado from becoming an EF5 was the lack of resources available, if that makes sense. Like I don't think that tornado was very well surveyed. Oh, talk about a throwback. Thoughts on ever looking into the Flint Beecher of 53. Michigan man Kyle coming at it. I'll have to dive into that one. I gotta do some old tornadoes. The videos would probably be shorter, but just because of the documentation. The Fargo one would be really cool, just because I would love to go back through some of Fujita's documentation of that. From was Fargo 1957? Which tornado that you have researched do you find the most interesting? I have to think about that. I don't know. There's a lot of different ones that I find interesting for various reasons. May you do an analysis of the Bowling Green? And of course, Bowling Green has they had another tornado today. I think, and Kelton, who was in the chat earlier, he also did a good video on the Bowling Green tornado and the, kind of these other tornadoes. Yeah, there's like that's the thing with these damage analysis videos is like there's like an infinite number of tornadoes and there will be continue to be tornadoes to like cover. Like very well, who knows what happens out of today, but like there could be, I could have to do a damage analysis on like today's event. A lot of people have opinions of certain tornadoes that were F5 EF5s should have been. What do you think? Do you have any tornadoes that were rated F5/EF5 you don't think were? That's an awesome question for my good buddy Colton Flint. Another great chaser. Subscribe to his channel. I think a lot of the F5s from back in the day are probably not F5s. Because the problem with the old F scale though is that it's like if you think the EF scale is subjective, then the F scale is like you can just look at it however you want, basically. Like the definition on it was like not very regimented and it wasn't super systematic. The EF scale got a lot better at that, and obviously it's still not nowhere near perfect and definitely is overdue for an overhaul, but Of all the EF5 tornadoes, thinking of the EF5s that probably didn't deserve. I think all the EF5s that have been rated deserved the EF5 rating. I'm cataloging through my head. Yeah, I think so. How big was the tornado? If we're talking about Mayfield, it was on the ground for 166 miles and had a peak width of just over a mile. Vicksburg, Belmont are ones that I think aren't EF5. Yeah, that's fair. Do you think any tornadoes will receive an upgrade or downgrade after the EF revamp? That's a good question. I don't know. Like, I don't know how, like, because I feel like the danger of, like, going back in time and re-rating, like, tornadoes is that, like, if you do it for one, then it's like, oh my gosh, then that opens, like, a can of worms that I'm not sure that the NWS wants to deal with. Six dead from tornadoes from today's event already. Damn. That sucks. Wichita Falls, April 79. I actually know someone that was, I think. No, I'm thinking, what was the one that impacted Fort Riley there in Kansas? I knew someone that was there for that. This is going to sound crazy, but Gerald's F5 should be called into question given how incredibly slow movement speed. Yeah, I mean, that Gerald's an interesting one because it's like that calls into like yeah, like the tornado itself was super slow moving and just like grinded over that community for however long, but it's like, isn't the tornado's forwards like isn't it still the tornado? Like, how do you differentiate that? That's the tough thing, what I have with that. Like, I get the argument, but it's like, how do you like reasonably separate that, if that makes sense? Like, how do you like differentiate? I don't know. It's tough. It's an interesting idea, though. I wouldn't mind seeing an analysis on a tornado that struck a city center. I'm wrapping up a research project that looks at urban. Oh yes, Emily, I wanted to see your presentation poster. I saw that on X or Twitter or whatever the heck I'm calling it, Twitter. Who am I kidding? The other day. And I was like, I saw the title and I was like, that's a really interesting idea. And I think a good case to look at would be the was it Fort Worth in 2000 or 2002? I think it was 2000. That might be a fun one to look at. IMO, if we have a radar truck recorded wind speeds of a tornado, I think we should be able to use that for the rating. For sure. Yeah, I think everyone's on the same. Like, if the information's available, use it, right? I think at this point, that's definitely, like... What do you think would have happened if a violent tornado were to hit a nuclear plant or power plant? Well, it almost happened in South Carolina a couple years ago. I'm pretty sure. And then the one in Amarillo has had a couple close calls. Keep in mind that radars can radars like you have from radars can mess up. Yeah, because I imagine you have to have like a percent error, and then like you have to account for like range folding and stuff that takes place with radars. The same argument about the Gerald being slow could have been about the Ely tornado. Eli, right? Yeah, Eli. By running over the same area twice. Yeah, that's a good point, Hunter. I like that. Good to see you in the chat. Yeah, Hackleberg almost hit a nuclear power plant too. Yeah, I think ever consider doing a documentary on the Windsor locks of 79? Yes, because that tornado is still in like the top 10 of like costliest tornadoes because it hit the New England Air Museum. And like the tornado terminated like 3 miles from where I grew up too, which is really funny. But Hackleberg was close, but well, yeah, exactly. Getting back to I'm sorry, I'm so like bouncing all over the place here, but in terms of like the nuclear power plant thing, like they all have shutdown procedures. They ever since 3 Mile Island, Chernobyl, any of those events, they're like the most craziest levels of preparation in place and procedures and stuff for if XYZ disaster, if there was like any sort of disaster to happen, they have protocols to isolate the reactor. So if there was like an F5 tornado or an EF5 tornado that hit a nuclear power plant, that it wouldn't be spewing radiation everywhere. They're possibly one of the most well-engineered things on the planet. Our nuclear power stations. Actually, yeah. Yeah, Hackleberg. I mean, the whole I wanted to do like a whole subset of damage analysis on the April 27th event. The time that it would take to do that is a lot. So I think I'm gonna have to really bear down and just grind them all out or something. Windsor locks ended just about where the June 1st EF3 began. Heck yeah. Hot take. Atomic Twister is the worst tornado movie ever created. I've never seen Atomic Twister, to be completely honest. Sounds like it could be rather tornadoes versus cities. It's a banger. Heck yeah, it is. Just coming on the tornado was the tornado in EF Clarksburg. I would say they don't know yet. Yeah, I saw that there was the spam or whatever is going on, but Connor seems to be locking it down. Good work, Connor. Damage analysis of the rolling house that they drive through on Twister. EF4 195. How about that? Only one person has seen an F5. Seems like the Tennessee, Kentucky area is becoming a December hotspot as of late. Well, it's the jet stream's a lot more crazy this time of year, that's for sure. Much more likely to get storm systems, and that's down into the Alabama and those southern states. They still got the moisture to make things happen. The last tour Twister was an F5, you monster. Thoughts on Rolling Fork getting an 195 higher than Mayfield? Good one. Uh, Rolling Fork. See, at the time I did Rolling Fork, because I did Rolling Fork not long after the event. I think it was still like 170. Maybe I have to go back and look back at the DAT. It's probably updated by now since I last looked at it, because the last time I probably actually looked at the DAT in depth for that event was for the video. I don't spend a lot of time on the damage assessment toolkit, to be completely honest. Ethan, would you be willing to take a look at some stuff I'm working on with a friend as for a history of tornado damage assessment? Project I've had at the back burner for a while and want some opinions. Yeah, man. Hit me up in the Discord or on Discord, and I'll help to the best of my ability. I got to be completely honest, guys. That I know there's a lot of stuff. There's a lot of stuff that I want to do in terms of videos. I have a video that's like halfway done right now. That I have to kind of shelf for a little bit. I have a kind of a couple life changes taking place through the end of the year. I'll have an update video, like kind of an end of the year video, kind of covering things. So yeah, going into 2023 though, or 2024 though, strong. We're gonna close out. I'm gonna have an end of year video. Well, I'm gonna cut this stream into a more condensed damage analysis of this event. So you'll see probably a re-upload of this video. End of year video, like I said, and then maybe another, like, the videos that I've been doing recently. The one that I'm working on right now, I will hint, is not a tornado event. Well, it did have tornadoes in it. And I will say the hint is Iowa. That should pretty much give it away, I would think. But that's like my next like well-produced video that's kind of in the queue. It's like halfway done. I'm pretty busy the next couple weeks though, so yeah. Yeah, this is a little confusing that I did this damage analysis video when, of course, another tornado outbreak happens. Yeah, not to cause any confusion, right? I'm sorry, guys, if there's any those of you that joined that thought that there was another Mayfield event. Yeah. Yeah, the chat's onto it. So you heard it here first. The next video is on the Iowa 2020 Rate Show. Kyoto on its way, baby. Woohoo. More, and of course, to Hunt a Storm. The next To Hunt a Storm will be the start of Clovis Fest. For those that were there, Hunter in the chat, will make several appearances in that in the next upcoming To Hunt a Storm episodes. Do you plan on doing a damage analysis on only U.S. tornadoes, or are you exploring other known tornadoes outside of the United States? Sorry, I can't read. Yes, there's other events that I want to cover outside of the United States. Some of the Canada tornadoes, of course, and some of the tornadoes that have occurred overseas. Just as long as there's like good documentation on it. Honestly, the Didsbury tornado this year had an extremely detailed survey. I haven't dove into it in depth, but Environmental Canada, hats off to you. I think also Western University did something with it. No, Western's in Ontario, isn't it? I'm not up to date with my Canadian universities, but yeah, Didsbury would be a fun one, just because of how well detailed that survey is and how much I think there's a lot of detail on it that is publicly available. So Grady, oh gosh, Clovis summer camp. That was so much fun for those over there. would love to see did. It's been requested, so I know there's a um oh, what's his name? I think he was here last stream. I think his name was Drake, and he was requesting Didsbury, and I was like, that'd be a fun international one to do. I mean, it's still North American, but was Great Barrington an actual F4, Mr. Massachusetts? Actually, I would be. I mean, the argument for Great Barrington is that yeah, it's the only reason why it did get F4 was because of that tossed car. Um, but outside of that, I mean, that tossed car was technically outside of the confines of the original F scale. So the argument could be made that it was, technically an F3, but it's on record as an F4. So, but I mean, there is a reasonable case to say that the Great Barrington tornado very well could have been downgraded. Connor, you still there? Cool. Yes. About Mayfield? Mm-hmm. Mm-hmm.
Be more friction, but no idea where the normal force would come from.
I just realized that Connor's volume was down. On,
No.
and now it's back. Um, I don't know if you're.
Do you want me to repeat the question?
Yeah, repeat the question, Connor. Your volume might have been
All
off
right.
for the entire
How
chat
do?
or for the entire stream.
Oh, that's not good.
Sorry, Connor.
uh, that's all right. The question goes: how do nails work in terms of like quote unquote holding things together? I would think it would be more like friction, but where would the normal force come from?
Okay. So like the like the toenailing of the studs, I'm presuming. So I think with that, those nails are not like it's like with nails, you're not going to get like any friction force, or really, you're not going to be resisting those tensile loads, really, right? So because I mean, Connor was saying things. Yeah, Connor's volume was off. I'm sorry, guys. Connor. Don't worry, Connor wasn't saying too much, but now we have Connor back. So, um,
Yeah, I'm here. I'm
and,
contributing now.
anyway, so yes, the so nails aren't really going to provide you much in that tensile loads. You have your what's it called, your sill plate, and then your stud, and then the nails up into there. And that's because like 99% of the time your house is like facing compressive loads, and those nails, all they're doing is preventing the studs from like moving like translationally. It's not really meant to like withstand really intense uplift forces. I guess if you really wanted to prevent that kind of stuff, use screws instead, but that's probably way more expensive from a building standpoint. I don't know how much more screws cost than nails. But I guess friction would be the only thing really resisting it. That normal force is like, yeah, it would just be pretty much friction. It's not like there's that much friction on nails. Heck, they're meant to go in like butter. Yeah, because that's the whole thing is that like nails, you don't really rely on nails in axial situations. It's all shear loads that you want to use nails for. So. Any other fun things, Connor?
We take a look. We can keep looking in that chat. Let me just keep scrolling.
Oh, I see. There's a couple comments about the explosion NATO earlier. Um, I wonder if it hit like some sort of substation or something, or some sort of big transformer Just freaking blew the thing up. Is Nashville getting hit by another tornado? What is going on today? Late season setups, man. I want to thank everyone for coming out to the damage analysis video. If you're just joining the stream or if you joined it like since you're just seeing my face, I did like a whole damage analysis thing at the I did the whole damage analysis presentation in the front half. If you missed that, I'm gonna be re-uploading this. I mean, now you can obviously watch the stream back too under the live tab on the channel, but I'm uploading and I'm gonna upload I'm gonna chop it up and take out all my ramblings that don't make any sense out of the live stream part and make it a nice condensed thing. So normal to see tornadoes in December. Yeah, I mean it's probably not as frequent as the spring months, but yeah, tornadoes can happen any time of year as long as the ingredients are there. Now, if you yourself had to rate the 190-mile-an-hour DI, what would you give it? Oh, Mark is asking the hard-hitting questions tonight. Let us pull back up the let's pull back up the presentation, shall we? Present. Oh. Swap. Oh, shoot. Alright, we're speed running the presentation again. Get back to the Bremen DI. Water tower analysis. Ah, here we are. Okay. The 190-mile-an-hour DI. See, that's the thing. Let's do this. You know what we can do? We'll pull up. Oh, live streaming. Okay. Enhanced Fujina scale. NWS. Let's have some fun here, eh? Enhanced Fujina scale NWS. Let's see if we can get the full. Let's go to 1 or 2 story family residence. Okay, here we go. Let's play Mr. Surveyor. Let's have some fun. Okay, so here we are. We have our DI. Half the foundation is thrown downstream. Let's take a look. Hunter will go take a look at the EF4 DIs by a lake in a second. I'll get back to you on that. All right, so let's see. I know my video preview is kind of... Oh, that's all the information we need. Typical construction, asphalt shingles. Prefabricated. Yeah, all this will work. Okay. Threshold of visible damage, loss of roof. Oh, we're definitely past that. Broken glass, definitely past that. Uplift on deck. Yep, past that. Entire house shifts off foundation. We're past that. Exterior walls collapse. Definitely past that. All walls. Destruction of engineered and or well-constructed residence. Well, this I believe classifies as a well-constructed residence. Slab swept clean. Well, the slab has definitely been swept clean and has been swept so clean to the point that it is literally no longer where the slab should be. So, I mean, just going off of the kind of the raw definition here, I mean, we can get into more scrutiny with the we don't care about the development of the EF scale, but you know, I think if I was given a convincing argument with other surveyors next to me, I think EF5 is on the table for sure. I could probably I'm like walking that line because it's like if that foundation was like built into the ground more. Hmm. Getting back to hunters. Here we are, Cambridge Shores. So there's a couple good. I wonder if we can go to what do we got for satellite imagery here. Oh. So there's none from December, but there is some after the fact. So it looks like, you know, they started tearing down some of these houses. How many of these are actually rebuilt, though? This is probably a... Yeah, look at that. So see, like, Cambridge Shores, you know, definitely a much more affluent area, lakeside property, right? So look at, like, all these, like, yeah, like, you know, a lot of stuff was impacted, but they're building back. You know, you can kind of slowly see what's that? Is that foundation there? And then watch if we skip ahead again. Boom, new house. Look at that. How far away did the other foundational pieces go? Mark, that's the problem. I am not 100% sure. It was hard. I was like trying to use the background to like triangulate how far it went, but I wasn't able to get a definitive answer. All I know is that it was displaced enough significantly where like oh, whoops. Hold on, what's going on here? It was displaced enough to the point where where are we at? That like in this view or this view, it's like you don't like see. Well, not like this view is very telling, but it's like you can't. There's no like. There's nothing. You can't tell where it went. Oh, we got a super chat. Arizona. Hello, Arizona. Didn't mean to come in so late. Overviewed what you said, and it seems like this is another W for the damage analysis. Go. Thank you for the super chat, Arizona, and your nice comment. I really appreciate it. And if you want to watch, I'm gonna try to condense this whole thing and upload it tomorrow. At least I'm gonna try to cut this thing up and upload it as a proper video as fast as I can. But any other questions or anything like that we want to talk about? If not, it doesn't have to be about Mayfield, but you know, let's take a look at some of these DIs. EF4. This is EF4. Numerous. Oh, it's like a general. Yeah, they're just like kind of broad sweeping a bunch of structures. Fair enough. Yeah. Oh, thanks for your second nice comment, Arizona. Yeah, these videos are the damage analysis ones are like, I mean, they take time, but the math like is kind of the easy part for me. The more involved videos that I've done lately, like the animated ones and stuff, like those ones take a lot of time. It's a lot of like tedious editing work. And of course, like the writing's much more involved. The These damage analysis videos are a lot more free flowing. Like I kind of just talk about them. I kind of just pick things that I find interesting in these damage analyses and kind of just talk to them and let my engineering brain go to work. Is that the house? It's like hard to tell. It's like there's a foundation or something. If F6, here's a cool question. If F6 was a rating that was used for unfathomable damage, what do you think would fall in the category of unfathomable damage? Is there any damage in recent that would fall into that category? I think one that, I haven't run the numbers on yet, and I get asked about it all the time. All in good time, folks. All in good time. There's only one of me, so it's hard to cover all of these. But El Reno Piedmont 2011, Doyle Derrick. That thing getting pulled out of the ground is pretty, that's hard to wrap your head around, man. So, thanks, Mark, for the super chat and your awesome questions. You ask good questions. I like that. You're making me think. Princeton University. Research Center DI on there? I thought so. I might not have a picture associated with it, though, Kurt. What are your thoughts on the high-end EF2 from July 2008? Ooh, I was throwing it back. I feel like I remember that tornado, too. Some 2024 Aurora / storm chasing gas. Heck yeah. Yeah, that might be the one that really kind of sticks out in my head. It's that oil derrick. And then I guess as a hypothetical, maybe a tornado that topples a skyscraper, but I don't know if that's physically possible. Skyscrapers are super, super rigid. At least the newer ones are. They have these really, really stiff concrete spines. Did you see that? See the intense tornadoes in Kentucky? Yeah, unfortunately. Beautiful picture in the background. Oh yeah, this is my this was in Montana back in September. This was to Medicine Lake in Glacier National Park. Right at sunrise. It was my first time in Montana. Awesome. I loved it. Great state. Think derechos will become more common since the big one in Iowa. We've already had we've had a number of there were multiple derechos technically in 2020. We had a derecho in the Northeast October 7th, 2020, technically classified as a derecho. So, that was a serial derecho though, not a progressive one like the one in Iowa. But derechos are definitely, I think with frequency wise, with El Nino in place too, more moisture and stuff. You get these northwest flow regimes kind of thing for these progressive derechos. And yeah, it just takes I Spy World of Warship. Yeah, that's the one game I play like that, and I don't play very many video games anymore, unfortunately. I'm too busy doing June 1st stuff. June 4th stuff is more fun. But I'm a big naval history nerd and World War II nerd, so that's why I like World of Warships. Yeah, I'm not. I have one tier 10 ship, and it's the Des Moines for those that. I like my U.S. heavy cruisers for those that play. Bunch of other tiers that have worked their way up. Master X Unicornly. I've seen you've been very active in the chat. I've just been. Uh, I'm going to leave now. Bye. Hope everyone had a great night. Thank you for the live June 1st. Glad to hear you liked the live stream. Yeah, World War II is just really interesting. Discovered you recently. I'm a meteorology nerd and came across analyzing storm damage from your engineering view. Has been absolutely fascinating. You do a fantastic job and found a great niche. Thanks, James. I really appreciate that nice comment. Ethan, I was wondering what your opinion on the true rating of the new Ren 2011, since it could have been what it could have been since it never got surveyed, and I think it couldn't rated EF4 plus. Oh, I think New Ren could have been the 5th EF5 that day. I'm in that camp for sure. Have you ever visited the USS New Jersey? I slept over on it when I was young. Not the USS New Jersey. I've been on the USS Massachusetts. I've been on the Intrepid, Salem, Lionfish. I'll get over. I haven't been on an Iowa class yet, but I'll get the first Iowa class I'll probably get on is New Jersey, if I had to guess, just because of proximity. Unless if I go to Hawaii or something really soon and see the Missouri. But the cool thing about the USS Massachusetts, which is a South Dakota class battleship, is that they stopped using them after World War II, so they don't have like the modern, like it's still in like World War II condition basically. Whereas like the Iowa class battleships have like a lot of more modern technologies since they served up through Desert Storm. Sorry for the naval nerding out here. You ever plan to chase snow or wind Monday? I thought about it, but I'm gonna be working Monday. Unfortunately, I'll be in the office. So June 1st isn't my full-time job yet. We're working towards it. We're trying to get to that point. We're trying to get there. But I gotta do my other engineering job to pay the bills. Crazy to think March 31st this year was one tornado away from tying the April 3rd outbreak. That is, yeah, in a 24-hour period. Any other interesting high-end EF4 DIs anywhere along the Mayfield track, as well as interested in Bowling Green? Oh, I wish I had the Bowling Green track downloaded right now. I don't have it. And the DAT is sometimes really slow when it comes with exporting KML files. Especially with the amount of DIs in here, it's understandable. But no, I think the EF4 DIs that I covered, were the ones that I was most interested in. I think those are the most important. I like trying to find lessons and learning lessons, and I think that 190 mile an hour DI is like the most fascinating DI that I've possibly ever reviewed, just because there's so much detail that I got out of it. And the fact that they installed a storm shelter, and they installed it in their house. Their house is barely 2 years old, and it gets hit by, possibly the worst tornado of the 2020s. So, well, we're closing in on 2 hours here. So, I think I'm going to wrap it up pretty soon here. Thank you for everyone for coming to the first ever damage analysis live. As mentioned before, I'm gonna cut up the first half of the stream into an actual damage analysis video. It's just gonna be pretty much what you saw here on the stream, but just kind of cut up more concisely and kind of stitched together in a nicer way, if that makes sense. It's a little more cohesive. Arizona, don't turn up your bit. Oh, is my thing lagging again? I'm sorry if my thing keeps lagging. We'll have some more details figured out for the next run at this. Oh, sorry, Josh. Well, that's all right, guys. I mean, um, there's gonna be plenty of more live streams to come, and we'll have more, and hopefully on days that aren't also tornado outbreak days. What's the weakest EF5 of 2011 in your opinion? Ooh, I don't know if there's a that's such a tough question to ask because it's like when is an EF5 weak? I can tell you the strongest. I think of all the 2011 EF5s, I think El Reno Piedmont takes the cake in terms of strongest in my opinion. I mean, you can make the argument for is it Smithville? I always get Smithville and Hackleburg mixed up, but Parkersburg EF5. Parkersburg EF5 is I did a damage analysis on Parkersburg and is in my opinion Parkersburg is the best example of a tornado recovery possible is Parkersburg. All right. In that case, guys, thank you so much for tuning into the live stream. Leaving all these nice comments and getting to discuss the Mayfield event. Obviously, it was a difficult event to talk about. Yeah, I mean, I still can't get over these two slides. This tells the whole story. The fact that these are before and afters of the same intersection is like remarkable. Have you thought about doing an analysis on Greensburg? Yes. Short answer, yes. There's trust me, there's like my laundry list of tornadoes to cover on damage analyses is like 50 deep by now. There's so many tornadoes I want to cover, but that's the thing. There will always be there's always something to talk about here on the June 1st channel. How about that? So, with that said, everyone, have a great rest of your night. Thanks for joining, and if you're in the risk area tonight, stay safe. Leave that weather radio on, have alerts, all that fun stuff. Get multiple ways to receive warnings. Got to close it out like the typical June 1st video. And as always, stay safe out there when it comes to severe weather.